you want to launch a mobile app, but you don't know what technology to use. Or maybe you're not sure whether to build a native mobile app or a cross-platform hybrid app for iPhone and Android users. Or maybe you're curious whether you can launch your mobile app using no-code and low-code platforms. In this video, I will answer all these questions and teach you about mobile app components and the best technology stack for your mobile application. If you pick the wrong technology for your mobile app idea, it will cost you a lot of extra time, money and effort. Technology mistakes are pricey. So in this video, I will do my best and try to give you everything I know and everything you might ever need to launch your first, second or 100 mobile app ideas successfully. Also, at the end of this video, I will give you a step-by-step algorithm for choosing a technology stack for each of your future mobile app ideas so that you can use it as a reference for years to come. So grab your coffee and let's begin. But before we start, who am I and why you should listen to me? I'm Vitaly Podoba, former software engineer turned software development agency owner. Since 2011, we helped over 200 entrepreneurs build and launch profitable web and mobile apps. Additionally, our agency successfully launched 2 own SaaS products. So all the information in this video about mobile app technology stack is based solely on my experience and agency portfolio. I talk about launching profitable software and mobile apps on my YouTube channel, so subscribe to learn more. What is technology stack? First of all, as a tech founder, you need to have a high-level understanding of the technology stack. In the construction industry, when a development team builds a house for you, they are using a combination of tools and raw materials like bricks, concrete, tiles, paints, and tools like hammers, screwdrivers, chisels, mixers, and so on and on. When building a mobile app for you, software engineers also use a combination of tools and raw materials. We call them programming languages, frameworks, extensions, libraries, databases, and servers. And if you are building your app on no-code platforms like Bubble.io, then Bubble.io is your technology stack. Mobile app components. Next, you need to understand a mobile app's technical components. There are 2 major things: front-end and the backend. Again, I will start by comparing it with house construction so it's easier to grasp. Everything you can see and use within your house is a front end. Walls, paintings, nicely done designs with decorations, furniture, house appliances, doors, windows, stairs, and so on and on. But everything that you cannot see and that serves as a foundation for your house, we would call backend. It's the concrete foundations of your house, it's the utility connections, tubes and wires that go inside of your walls and floors that are vital for the function of your building. Usually you don't see them. For example, when you use water in your bathroom, you can only see the front end part of it, the faucet in the shower. Similarly, the mobile app also consists of front end part, also known as the mobile app or client side, and the backend, also known as the server side. The backend also consists of brains, the logic, and the data, also known as storage or database. Now we are finally ready to start talking about programming languages, frameworks, and specific technology terms. And we will do it step by step because your app's backend, front end, logic, data each require their own set of tools and technologies. Let's start with the front end. What is the mobile app front end? We can also call it client side or simply a mobile app. App frontend is the visual part of your application. In other words, it's a file users can download online from the marketplace, install it, and use it on their mobile devices. This is what we technically call the front end. The front end consists of all the forms, pages, and screens your users can interact with. Any customer-facing front-end must be designed by a professional team of user experience specialists and designers. With better design, it will be easier to get new users and to keep existing ones. So, custom design and user experience is the essential step in developing any mobile app interface. One more thing you need to decide during the planning stage of your application is whether it will provide some local data storage. In other words, is your app useful or usable offline without the internet connection? Offline modes are usually time-consuming to develop, so it's a big decision to consider at the beginning of your development process. Now, regarding the technology stack for the front end, there are 2 ways to develop mobile apps: native and cross-platform, also known as hybrid approach. What approach to choose for your mobile app? Native or cross-platform, also known as hybrid approach. Let's start with the native approach. What does it mean to develop your app using native approach? Back in 2008, right after the first iPhone release, Steve Jobs also introduced the App Store, which was the beginning of the mobile apps era. At that time, software engineers could build iPhone apps using Objective-C programming language created by Apple. A bit later, in September same year 2008, Google and Microsoft jointly released the Android mobile operating system. However, to develop mobile apps for Android, software engineers had to use Java as the programming language. So, if you want your app to be available for iPhone lovers and Android users at the same time, you have to hire a developer who knows Objective-C language, develop mobile app using this programming language, and then submit this app to the Apple Store. Then you have to hire another developer who knows the Java language, implement separate app from scratch with the same functions using Java now, and then submit the second app to the Google Play Store. Yes, this native approach is quite expensive because you are literally paying twice to build two different mobile apps. The same goes for maintenance and support. Every time you need to fix a bug, you need two different devs to fix the same bug in two different apps. This is what we call the native approach to building mobile apps. However, in 2009, 1 year after mobile app stores were released, the first cross-platform framework was also released. So, what does it mean to build your mobile app in a hybrid cross-platform way? You hire one software developer who knows one programming language. In most cases, that will be a JavaScript language. You ask the developer to build your mobile app once and then release it to the Apple Store and to Google Play Store. So, your development efforts, time and budgets are cut almost twice, as well as your support and maintenance resources. These days, we've got many cross-platform frameworks, such as React Native by Facebook, Flutter by Google, Xamarin by Microsoft, Apache Cordova by Adobe Systems, and Ionic by Drift.co. In my agency, we used Xamarin, Flutter, Ionic, and React Native frameworks to build mobile apps for our clients. But the one that we like the most is React Native. Facebook did really great job spreading its framework and making it quite efficient and easy to use for developers. As a bonus, the React Native framework uses the React.js JavaScript library, which can also be used to build web apps. So if you need both web and mobile app for your project, you will save up to 70% by reusing your mobile app code within your web application. This way, you save twice again. Now you might ask me, Vitaly, if cross-platform mobile apps are so great, why would you even consider a native approach? So, what are some pros and cons of native and cross-platform approaches for mobile apps? With cross-platform or hybrid mobile apps, you don't need to build the app twice. Single developer, single programming language, and single codebase will work both for iPhone and Android devices. So you pay less and get your results almost twice as fast. It's also much easier and cheaper to support and maintain a hybrid mobile application than a native app. Finally, if you need to build a web app as well, you can split your development between the web app and mobile app as well. But there are a few scenarios where you will need a native mobile app or where a native mobile app will work a bit better. Native mobile apps have better access to mobile device processes and hardware, such as camera and video editing, wide range of sensors like gyrometers and accelerometers, CPU and GPU for intensive graphics rendering, NFC, Bluetooth, biometric sensors, storage management, and push notifications. So, if you need to build visually intensive game, video editing tool, or virtual reality app, for example, you will most often have to build a native app using programming languages like Objective-C or Java. Also, native apps have direct access to device hardware and APIs, which makes them a bit better at performance. This is crucial for resource-intensive mobile applications like trading apps, for example. But in other 95% of scenarios, I will guarantee you a cross-platform hybrid mobile app will do the job for your project. Let's take Instagram. Its mobile app is built with a React Native cross-platform framework. If your mobile app is not more complex than Instagram, then you will be fine using something like React Native too. A lot of things are said on cross-platform apps, but it's a very important topic, and making mistake here would be probably the most expensive mistake that you will make as a mobile app founder. So let me summarize on technology stack for the frontend. You can develop your app as a native mobile application, and in this case, your developers will use Objective-C language for iPhone apps and Java programming language for Android phones. If you go for a cross-platform mobile app, you have a few options here as well. React Native, one of the most popular these days from Facebook. Here your devs will build an app using JavaScript language, React.js framework and HTML, XML as a markup language too. If you pick Flutter, your technology stack will be Dart programming language. If you pick Xamarin, then your app will be built using C# language by Microsoft. If you pick Apache Cordova or Ionic, then your programming language will be also JavaScript. Now we are officially done with the front-end part of our mobile applications. This was the biggest part because it's a mobile app itself. Comment below what approach would you pick for your mobile app, native or cross-platform hybrid approach. Now we are ready for the second major component of almost every mobile app, the backend for the mobile app. In rare situations, the front-end is the only component you might need to build. For example, mobile apps like calculator or clock that all of us have on our mobile devices. These are standalone apps that don't keep any data long-term and they keep all their logic brains within your phone. However, if you are building a mobile app to sell and make some profit from it, you will need a backend in most other cases. The backend is a central server, we can also call it a production server, that is publicly available for all the mobile app installations for all your app users. We need the backend to keep the user data, collect payments online, track user authentication sessions, do all the logics and calculations, and to process user input from the mobile app. Also, when a mobile app user buys a new device and installs on their phone, he or she wants to access the same data that was available on the previous device, previous phone, right? That's why we need the backend. The mobile app, the front end, talks to our backend to pull data from it and to push user data back to it. The most popular protocol for this communication is REST API. And the most popular data format for it is JSON. You don't have to worry too much about this, it's engineering stuff now, but I decided to tell this just so you know. The backend consists of two other components: the brain, we can also call it the logic, and the data. We can also call it as a storage or database. So let's consider each of these two backend components separately. Mobile app data, storage and databases. I would say that storage is the heart of our software. It keeps all the app data collected from our users. Without data, everything else does not matter. In the end, our users and their data matter the most to the success of our software business, right? The most popular SQL databases are PostgreSQL, MySQL, Oracle, a Microsoft SQL Server, and similar. In our agency, our favorite is PostgreSQL. It's super reliable, it's scalable, and one of the most popular and free to use. Also, if your developers need a non-SQL database, the best choice is usually MongoDB. The last thing I want to mention regarding data storage is that in most cases, your developers will not work with databases directly, but via so-called bridges, ORM, which stands for Object Relational Mapping. It makes developers' lives much easier as they don't have to remember all the nuances of SQL language when making database queries. The most common ORMs on the market are Django ORM, SQL Alchemy, SQLize, Mongoose, and Hibernate. Mobile app brains and the logic. While the mobile app frontend is the face of your application and the data is the heart of it, the code and the logic that connects data with the user interface are the brain and blood of your mobile app. The brain serves as a middleman between data and users. It processes data smartly and returns processed data to the user. What technology do we usually use to build the brains and the logic of our mobile application? On the backend server, we are using a similar technology stack to build the logic for web apps and mobile apps. If you would like me to make a new video explaining the full web app technology stack, comment below. If I collect enough requests, I will make that one too. It all starts with programming languages. On the backend, you can use anything like Python, PHP, Ruby, or JavaScript. These are some of the first choices that will let your developers build fast and cost-effectively. These are popular, dynamic, and free-to-use languages on the market. But nobody builds apps from scratch these days. Most developers will use a framework to avoid building an application system from scratch, a building function from scratch, database management interface from scratch, and so on. For example, for Python, we have frameworks like Django. For PHP, Laravel. For Ruby, Rails. And for JavaScript, Node.js. Since 2011, our agency has used many tools and frameworks, but our favorite combination is Python and Django. With Python, we can build not only web and mobile app backends, but also AI and machine learning solutions and many other different types of software cross-platform. Finally, depending on your app idea, your dev team might need to use some specialized tools, libraries, add-ons, services, and APIs to cover specific functions like WebRTC for video streaming, Stripe or PayPal APIs for online payments, or Socket.io for chat applications, or Twilio service for calls and messaging. And the most important question for your mobile app, brains and logic, is to pick a proper programming language and a framework. That's it. No code vs code solutions for mobile apps. Until now, I've been explaining to you what technology stack to use when you and your team build an app with code. However, I often get questions from our new clients about whether it's possible to build their mobile apps with a no-code solution and thus save some time and money. I'm not going to give an extended answer here in this video as it would require a separate long-form video, but if you want me to do so, comment below and I will do it if there is some interest in this topic. Over the last few years, there have been a rise in no-code and low-code solutions for building software. These days, it's even possible to build basic mobile apps with no-code platforms like Bubble.io. So, do you need to consider no-code platforms to build a mobile app? It depends. It depends on your goals, your app requirements, and your resources. That is true that building an app with no code will be faster and a bit cheaper than hiring a software engineer to build it from scratch. You will still need to hire a no-code engineer, but in that case, we assume that a template for your specific idea was built before many times so that the no-code engineer can reuse it. However, the problem is that no-code platforms in their current form are pretty limited. To build more complex mobile apps, your developer will still need to write some code at least. In many cases, your mobile app idea cannot be built using the no-code approach at this time. Honestly, it's hard to find really big and popular mobile apps built with no-code platforms. It's pretty obvious that no-code usually goes as far as testing and prototypes, and once there's money in the house, founders rebuild their apps from scratch with code and with software engineers. Anyway, these are some of the relatively popular mobile apps built with no-code platforms. The Cycles app built with Adalo, Coins built with Bubble.io, Pearson Automotive built with AppSheet, OES Review built with Tankable. So if your mobile app can be built with no-code platforms, and unless you really don't have enough budget, that would be the only case when I would recommend you building your mobile app with no-code or low-code solutions. The best technology stack for your mobile application. So far, I overloaded you with a ton of new words, terms, programming languages, backend, frontend, databases, low-code, no-code, and code solutions. But no worries. Now, as I promised, I will give you a step-by-step decision-making algorithm for what technology to choose for your specific mobile app idea. Step number 1, no-code platforms. Avoid it if possible. The only reason to use it, you are very limited on budget. In future, this might change, but for now, these platforms are quite limited. Step number 2, hybrid or native mobile app. In 95% of situations, your mobile app can be built as a cross-platform hybrid application. Build a native app only if completely necessary. This way, you avoid paying twice for your app. Step number 3, the front-end. Facebook's React Native environment is one of the best for hybrid applications. The React.js framework combined with JavaScript programming language forms a killer combination for any hybrid mobile app. In our agency, we have tried many mobile app frameworks over the last few years, but React Native is a winner by many criteria. Step number 4, the backend. Python is our favorite server-side programming language. Companies like Google, Facebook, Instagram, Spotify, NASA, Netflix, and Dropbox use it. It's good for web and mobile app backends and also great for AI, machine learning, and data science. You will never be wrong if you pick Python for your server side. Together with Django framework, this is one of the best combinations, and it's open source. Step number 5, storage. Choose PostgreSQL as your main database. It's the most popular, reliable, and free to use. Choose MongoDB if your developers need a NoSQL database to add to your main storage. The final step, step number 6, hosting and servers. Use DigitalOcean Linux-based Droplets for reliable and easy to set up hosting and servers. Use Amazon AWS if you're willing to pay a bit more and get a bit more sophisticated and scalable environment and solution. We use this technology stack to build many mobile apps for our clients. For example, this mobile app for the construction industry, Buildwise, which we built for one of our clients from Canada, is built using Python, Django, and the React Native framework. Of course, each mobile app is unique and might require some adjustment to this technology stack based on its size, complexity, scope, and budget, but if you follow my algorithm and choose the the stack I just recommended, you will be right in 95% of scenarios. For the last 5%, apply for my consultation using the link in the description below and I can help you with that. Building a mobile app is one thing, but supporting and maintaining it is a completely different story. If you also want to learn how much time and money you need to keep your mobile app up and running, here's another video on this topic. Now I'm wondering, would you build your mobile app as a native or cross-platform application? Let me know in the comments below. Also, if you're interested in having my in-house developers build your mobile app, I will include a link below this video to the application forum so we can help you. If you enjoyed this video, please hit the like button and subscribe to my channel to help me spread the word. See you in the next video.